Now we're next going to consider an example that uses the second algebraic method for solving a system of linear equations, and that would be the elimination method. Now you just learned that the first step in using the elimination method is to be sure that both equations are in standard form, which they are here. Now remember that standard form means having the x and y terms on the same side and the constant terms on the other, with the x terms listed first. Now the goal of the elimination method is to add the two equations so that either the x terms or the y terms will drop out. And to do that, the x coefficients need to be opposites of each other, or the y coefficients need to be opposites of each other. So it would be my judgment in this case it's probably going to be easiest to eliminate the y terms. So if we were to multiply the second equation here by 2, we'll end up then with the following. Now the first equation will stay the same. So 2x plus 4y is equal to 10. And multiplying the second equation by 2, we end up then with 8x minus 4y is equal to 12. So you can see now that if we add the two equations, the y terms will drop out, and we're left then with 10x is equal to 22. Our x then is equal to 22 all over 10. And if we reduce that, we're going to get 11 all over 5. Now to find the y value, what we'll do is substitute the 11/5 back into either of the original equations. And I think I'm going to use the first equation just because it looks a little bit simpler. The coefficients are smaller, so we're next going to find y. So let's take the first equation. I'm going to substitute then into the first equation. 11 over 5. And plus 4y is equal to 10. So we'll have 22/5 plus 4y is equal to 10. And we'll subtract then the 22/5 from each side, so we have 4y is equal to 10 minus 22/5. And we'll get a common denominator here, so this will end up being 50 over 5 minus 22 over 5, or 4y will be equal to 28/5. And to finish, what we'll do then is simply multiply each side by 1/4 to make the coefficient of y positive 1. So we have 1/4 times 28 over 5. And I think you can see that we can do some canceling here to reduce. So 4 into 28 will be 7. So then we're left with y being equal to 7 over 5. So now we'll express the solution then as an ordered pair. So we would then write the ordered pair 11/5 and then 7/5. Then what we'll do next is to check that ordered pair in one of the original equations. Now let's next check the solution we just came up with, the 11/5, 7/5 in one of the original equations. I'm going to choose equation 2 here. So what we'll have then will be 4 times the quantity, 11/5, minus 2 then, times the quantity 7/5. And we hope that this will work out to be equal then to positive 6. So multiplying the first term on the left-hand side here, we end up with 44 all over 5. Minus multiplying the second term, we have then 14 all over 5. And 44 fifths minus 14 fifths turns out to be 30 over 5, which will simplify to 6. So we can see that the ordered pair does satisfy the second equation. And again, it will be good practice for you to check this ordered pair in the first equation.